In this video, we're going to be discussing vectors. We're going to learn about what vectors are. Then we're going to learn how to add and subtract vectors, which is going to be using several different methods. I'm going to show you how to use the head to tail method, and then I'm going to show you the matrix method and how you can do all of this on Desmos. Okay, so what a vector is, it's a measurement that also has a direction associated with it. So let's say you do a measurement, and that measurement is 25 meters. Okay, so 25 meters would be a scalar measurement. It's not telling us any direction or anything. But if I said 25 meters and it is headed eastward, now I know that the length of this line is 25 and it's pointing to the east. Now that's really easy to work with. Also, it would be really easy to work with if I had a vector that's pointed straight up, and let's say that this is 5 meters and it's going north. That's really easy to deal with because I can tell that the magnitude, so how big is this arrow, is 5 meters. Now let's say we have a vector that is up and to the right, and we know that it's some angle off the horizontal. This angle, this magnitude is going to be based off of this angle, and it's a little bit harder to work with. What we would actually do is if we were given these values and we had to add it with other vectors, we'd have to see how much of this vector is moving left and right. So how much of this is horizontal? And then we also want to know is how much of this vector is vertical? How much of it is up and down? And we could find out all of these things, and we could actually relate all of these concepts together, because I know that this is a 90-degree angle, and I know that I could use the Pythagorean theorem where I have a squared plus b squared equals c squared. And what we're going to do is we're going to look at the relationship between all of the components and the overall magnitude of a vector. Now this breaks down all of the concepts that we're going to go over first. If I have a vector just like that black vector, and I want to know its components, and let's say that I know what the magnitude is. So let's say instead of x, let's say it has a magnitude of 25, and the angle is 60 degrees. If I wanted to know what the horizontal component is, so how much of it is going horizontally, this would be 25 multiplied with the cosine of 60. If I wanted to know what the vertical component is, this would be 25 multiplied with the sine of 60. And that would tell me exactly how much of it is going in the horizontal direction, how much of it is going in the vertical direction. I already know what the overall magnitude is. This tells me how much of it is left and right, how much of it is up and down. Now, if I wanted to figure out what this angle is, let's say I don't know what my angle or my magnitude is. So I don't know this and I don't know this. But let's say I do know that my horizontal component was 12, and let's say that I do know that my vertical component is 25. Now, if I wanted to figure out what my angle is, I could actually use trigonometry because this is a right angle. Remember, this is a 90-degree angle. This is some angle. I could use trigonometry. And my vertical, I would do inverse tangent of my vertical, which was 25, divided by my horizontal, which was 12. And if I plug this into my calculator, it'll actually give me a value. Let me take a moment and do that real quick. So I have inverse tangent, 25 divided by 12. Gives me an angle of, let's go with black because this is resulting, we'll go 64 degrees. Okay, and if I wanted to find out what my magnitude is, this is going to be my horizontal squared plus my vertical squared. My vertical is 25. And I could see that my resulting magnitude is going to be 12 squared plus 25 squared gives me about 27.7. So my magnitude is 27.7. All right, so what we see is if I know my magnitude and my angle, I could find my components using sine and cosine. So to find my horizontal, I use cosine. To find my vertical, I use sine. Now let's say I don't know my magnitude, I don't know my angle, but I do know my components. If I know my components, I can use these right here to find out what that angle is and what is my angle. All right, so that gives us a rundown of how we use trigonometry, really. That's how we use trigonometry with vectors. now what we want to do is we want to add vectors. So here we have two vectors. Let's call the red one v1. So this is v1, and let's call the blue one v2. Now just running through this real quick, I can see that v1 has a horizontal, so how far is it in the horizontal direction? It goes over 5, and it goes up 10. So using what we just learned, if I wanted to know what my resulting vector is, this is going to be square root of 5 squared plus 10 squared, which tells me that this overall vector, the size of my vector, is going to be 11.18. And if I wanted to know the angle here, my angle is going to be 63.4, and that's going to be based on, so this 11.18, my angle is inverse tangent of my y divided by my x, so my vertical divided by my horizontal, and this would give me 63.43. All right, so that's how we take our x component and our y component, so it's horizontal and its vertical components, and we find the resulting vector, and we also find the angle. All right, so let's do that again with v2. All right, so to find our resulting vector, that's going to be the square root of my horizontal component, which is 5 squared, plus my vertical component, which is going to be 0. Okay, 5 squared is 25. The square root of 25 is 5. So this tells me that my entire magnitude is right here. Because it is not split into components, there's no part of it that is going upwards. It's all just horizontal. We get a total magnitude of 5. And its angle, we could see that it is along the x-axis, which means its angle is also 0. All right, head to tail method. We want to add these two vectors together. I want to add all of the horizontal and vertical components of v1 with all of the horizontal and vertical components of v2. And I want to see, once I combine those and they combine with each other, what is going to be the new vector that this makes when it takes all of the horizontal components and puts them together, puts all the vertical components, puts them together. What do we get? Head to tail method says we take our first vector. So I'm going to take vector 1, and I'm just going to draw it as it is. And I know that this has a horizontal component of 5 and a vertical component of 10. So this is its horizontal component. This is its vertical component. And then I'm going to take my second vector, my blue vector, and I'm going to draw that one. And head to tail means that I take the head of my first vector and I place the tail of my second vector on it. So the tail is the part that doesn't have the arrowhead. All right, so for this vector, I have a horizontal component of 5 and a vertical component of 0. Now for the head to tail method, what we do is I start at my beginning spot and I go all the way to my ending spot. So I go from my first point to the end of that succession of arrows. And this would be the resulting vector. Now I could see that it goes far more to the right than the other one did, and I could see that it goes up as high as my red vector, and I don't know what the magnitude is going to be. I don't know what this would be. If I were to measure that black arrow, I don't know what it would be right now. But I can see that it has all of the horizontal components of my two vectors, so I could see that the horizontal component of this black vector is going to be the horizontal component of my red one and the horizontal component of my blue one, which gives me a total horizontal component of 10. And I can also see that the vertical components are going to be all the vertical components of my two vectors. So my red vector had a vertical component of 10, and it had a vertical component of the blue vector of 0, which gives me 10. Okay, so I can see that when I add these two vectors together, I get a new vector that has a horizontal component of 10 and a vertical component of 10. Notice that this is not the same as either one of these individual vectors. It's a combination of both of them. Okay, so now what I want to do is I want to look at just this new vector that we got. Okay, I'm going to do the same exact things that we did last time. I'm going to say that my magnitude, so this resulting vector, so my resulting vector is going to be the square root. My horizontal component is 10. My vertical component is 10. Both of these have to be squared. And it tells me that I get a resulting magnitude of 14.14. 14.14. Okay, so my magnitude is 14.14. Now my angle. How do I find the angle from the horizontal? Well, I find the angle from the horizontal by my angle is inverse tangent my y over my x. So this is going to be 10, which is my y, divided by my x. So my vertical divided by my horizontal gives me an angle of 45 degrees. Anytime your vertical and your horizontal are the same exact number, you get 45 degrees. Okay, matrix method. Now let's take a look at matrices. I like this one. This is my favorite method. What we do is we arrange our vectors into its x and y components. So our x's are going to go on top, our y's are going to go on the bottom. So let's say we have v1. This would be, now if I didn't know my components, let's say I didn't know that my x was 5, but I did know my angle and everything, I could say that this is 11.18 cosine 63.4. And on my bottom, my y component is going to be 11.18 sine 63.4. That would be how I get my values. I know what these values are, so I'm going to make it simpler, but just letting you know that's how you'd break its components down. You'd put it into vectors like that. So its x component was 5, its y component was 10. My next vector, so looking at v2, so I'm going to add this to v2. X component goes on top. My x component is 5. My y component was 0. Now I'm just going to add straight across the rows. So rows are left and right. Columns are up and down. I'm adding all of the rows. So my resulting vector, this is going to be 5 plus 5 is 10. 10 plus 0 is 10. And I can just do the math now. So once I get this, I know that my resulting vector's magnitude is going to be 10 squared plus 10 squared, square root the whole thing. We got the answer in the last question. If I wanted my angle, this is going to be the inverse tangent of my y divided by my x. So this is going to be 10 divided by 10. All right, so that's how we do everything. That's how we can describe a vector, how we can break it into its components, how we can add vectors using the head to tail method, how we could use the matrix method. Now let's take a look at how we could actually use Desmos. So with Desmos, all we do is we write out our vectors. So v1, I'm going to always start everything at the origin. So what we do is we put 2 points for our vector. We start at the origin, and then for our second point, we put our x component and our y component. So we put how much horizontal, how much vertical. So I'm starting at the origin at 0, 0. And then my second point is going to be my horizontal component. So my horizontal component for my first vector was 5. My vertical component was 10. I'm going to put 10 right here. And now I have my first vector. Let's label it red so it stays with the same color scheme that we had before. So there's my first vector. Now what I want to do, I want to make my second vector. Again, always start at the origin. So my origin is at points 0, 0. And then we put in our x component. So my x component for this one is 5. My y component is going to be 0. Now if I knew the angle and the magnitude, let's say that I had a diagonal line. So like for this one, I could also put 11.18 cosine 63.4. And it'll still work. We can see that because I rounded this, we get a little bit off, but it's still 5. You can do the same exact thing if you needed to do that. So I'm going to put this back to 5 just so we can keep everything without any rounding errors. Okay, I'm going to turn this one to blue so it looks just like it. All right, now I can see, let's make this a little thicker actually. Let's go with 10. Oh, that's only for the points. My line, I want to make this 5. There we go. Okay, so I could see my first vector, this red one, is located right here. I could see my blue vector located right here. Here's how easy it is to add vectors on Desmos. I just go v1 plus v2. There's my resulting vector. They even put it in black for me. There's my resulting vector. If I look, when I did the HUD to tell method, it was going up and to the right. Now if I look at Desmos, up and to the right, I could even see what its values are. So my x component, so my horizontal component for this resulting vector, has a horizontal of 10, vertical of 10. That's exactly what we saw before. Now I could do the same thing. I could say inverse tangent, so 10, negative 1, 10 divided by 10. And I want to make sure, so this is already in degrees. If you don't have it in degrees already, make sure you click right here in degrees. You don't want it in radians. All right, then if you want to find out your magnitude, you're going to go NTHROOT, make sure it's square root, and then we go 10 squared plus 10 squared. And I could see I get 14.14, just like we saw right here. So you just write out your vectors, add your vectors together, gives you your resulting horizontal and vertical components, and then you could use the inverse tangent and the Pythagorean theorem.